So as we continue our conversation on ratios, we've got the basics kind of down pat, which we've seen in the first video. But now we want to take it and talk about two concepts, and it's going to be new for you. It's going to be called, you're going to see scaling up and then scaling down. And this will be kind of the focus of this video, is how we scale ratios up and down. And so to kind of show you this, I want to present an example, something that we can kind of wrap our minds around. And let's just say, for example, and I know a lot of you folks are sports people, and some of you even play soccer. So let's use soccer as our backdrop. And we're going to say that we've got a co-ed, meaning boys and girls, soccer team that has 4 times as many boys on it as it does girls. So we would, based on our first lesson, we would be able to look at that and say, well, if there are 4 times as many boys as girls, we could say that this is 4-to-1 is the ratio. Now, we also talked that we could express that using a fraction, and we could say if we're talking how many, how much of the team is boys, we could say, well, that is 4 out of the 5 players, or we could flip that and say if we're looking at girls, 1 out of the 5. But here's the thing for my soccer folks. You know that 5 players is simply not enough to get it done on the soccer field. So what we know, and let's just kind of get the basic information down. When it comes to number of boys, we know that there are 4. When it comes to number of girls, we know that there's 1. And then our total would be, we can add those up and get 5. Well, ultimately, and I'm going to come over here and let me say, I'm going to say, we'll just say, let me put this here, and I'll just put total. So we need a total. Right now we have 5. But honestly, we need more than 5. We need, let's say, 20. 20 players would make for a really good. Or, and we can play with that number, but just for an example, we can say 20. If I had 20 players, I'd have probably a pretty competitive soccer field. But having 20 players, I need to maintain that ratio. So what I need to be able to do is I need to look at when 5 went to 20, obviously it got bigger. And we want to think about this in terms of multiplication. What happened from a multiplication perspective? What happened to 5 for it to get to 20? So one of the things we don't need to say, well, it added 15. And that's not going to be very helpful because A, that's not multiplication. And B, when we see these relationships, whatever we determine on one of the numbers, it has to hold true for the rest. So what I know when I go to my basic facts is that 5 times 4 is 20. So that relationship that I've just established can hold true across the board. I can come and say, well, using that information, I know that 4 times 4 is 16. And I know that 4 times 1 is 4. And so I know that I can have a ratio of 4-to-1 boys to girls and still have 20 players, but you'll notice that my actual number of boys is 16 and my actual number of girls is 4. What I've just done is called scale up. I took a ratio that did not represent all that I needed in terms of the number of players, and I scaled it up to be able to reach how many players that I actually needed. And we can do that on the back side as well. What if, and again, we'll use the same scenario to kind of use as our backdrop for an example. What if I have a team that has 24 total players, and this one's going to have more girls. It has 6 boys and 18 girls. Now, the first thing I want to always do is check my math. Just make sure 6 plus 18 does equal 24, so we're in a good shape. But I want to know, hey, what is my ratio? Now, on one end, I could say, well, Mr. Elliott, that's easy. I know that the ratio is 6 boys to 18 girls. But I want to be able to scale it down to get it into a number that I can kind of wrap my mind around. And so what I want to do, and when we scale down, it's a little more difficult, but I think it's more important, to be honest with you, than scaling up, because I can break it down. And honestly, we're kind of bridging our way to what's called a unit rate, and we'll get there in the next lesson. So I'm kind of giving you a preview of what that unit rate might be. What I want to do is go take the numbers and decrease them, but when I decrease all three of the numbers, I want to decrease them by the same operation. Well, if I increase them when I scaled up by multiplication, the opposite of multiplication in this case is going to be division. And so when I come down, what I want to know, is there a basic fact, a basic division fact, that I can divide all three of those numbers? Because here's the deal, I don't want to get into any situation where I have decimals. Everything should stay at whole numbers right now. Now, as you grow in your math, then it'll get a little more complex. But for right now, we're just trying to get the concepts of scaling up and scaling down. So I'm not going to be putting any kind of math that you haven't seen yet. But what I know is 24 is divisible by 3. I also know that 6 is divisible by 3, as well as 18 is divisible by 3. So I could start there. And I'm going to divide each by 3. And I know that I could get 8. If I divide 6 by 3, I would get 2. And if I divide 18 by 3, I would get 6. And I'm going to stop just real quick. My check every time is going to be, I want to add the boys and girls up to make sure it matches the total. So I could say, well, 6 plus 2 does equal 8. So I'm in good shape. But as I look at it, I notice that they're all even numbers. And there's something I know about even numbers. All even numbers are divisible by 2. So I haven't scaled down enough. Now, on one end, I have scaled down appropriately. I can still say for every 2 boys, there are 6 girls. Or I could look at this and say that in my total, 2 of the 8 will be boys, right? I can use a fraction. Just remember, if I use a fraction, that my denominator is the total, not the other value that we're using. So I can, but I'm still not scaled down enough, and this might happen to you from time to time. So all I want to do is go, I need to go down further. And I notice, if I can divide those all by 2, 8 divided by 2 would be, I can bring that down to 4. 2 divided by 2 would be 1. And then 6 divided by 2 would bring me to 3. And now, I'm actually as low as I can go. If you ever hit 1, just stop. If either of your numbers hits 1, stop. You're where you need to be. So I've noticed that I am actually, for every 1 boy, there are 3 girls. Or 1 in 4 players is a boy. Or 3 in 4 players are girls. And so I've scaled this number down multiple times, and you may see that you need multiple steps. So there might be a time, let me say this before I jump into what to do if you don't see your number. Notice here, I divided by 3 and I divided by 2. If I multiply those two numbers together, I get 6. And so one of the things is I can come back up here. If I would have just divided by 6 to begin with, I would have got the 4 there, divided by 6, and got the 1, divided by 6, and got the 3. And now I've got my ratios. And so that's all we want to just before you jump in and start going, I would if you see the 3 or you see a 2, it's easy to want to start there, but work your way up a little bit and just make sure, is there a bigger number? It just may save you a few steps along the way. So this is what scaling up and scaling down is. And we just want to remember, if we scale up, that we're multiplying each of the three numbers to help us scale up so that the relationship stays the same. And likewise, if we scale down, we want to make sure that we divide by the same three numbers all the way across so that the relationship stays the same. And that's the key part of scaling up and down, is we don't want to lose the relationship between any of the values that we're using. So today's practice will focus on scaling up and down. One of the things that I just want to kind of point out to you is you may not see the answer you want. And if that's the case, don't second guess your math or go guessing. Make sure that you scale up enough or down enough. You might just need one extra step.